For this first video, we're going to look at left-hand and right-hand Riemann sums. So what these are is Riemann sums are a way to use rectangles to estimate the area underneath a curve. So the function we're looking at is f of x equals x squared plus 1, and I've got a graph of both here. And we are going to look at an estimation of the area from x equals -1 to x equals 2. So from here to here. And we have a delta x equaling 1/2, so that's how we're going to split it up. They could also have told us to split it up into 6 different rectangles, because if we use a delta x, a change in x of 1/2, you'll see that you have 6 different regions here. 1, 2, 3, 4, 5, 6. Now each one of these little intervals here will serve as the base of one of our rectangles. So each one of our rectangles has a base of 1/2, which is another way they could have phrased the question. Okay, so for our left hand, the first thing I'm going to do is draw it. So the left hand rectangles means that for each one of these intervals, like this first one has a base of 1/2, I'm going to use the left hand side to decide what the height of my function is. So, and the height of my rectangle. So I go to the left all the way up to the function, and that will be the height right here. It's the height of my first rectangle. So I'm going to go to the right and down. For my second rectangle, this is the base from -1/2 to 0. I'm going to go to the left-hand side up to where it touches my function, and that will determine the height of my rectangle to the right and down. My next rectangle is from 0 to 1/2. The left-hand side for the left-hand rectangles will decide the height, so it goes up to here, to the right, and down. The next rectangle will have a base from 1/2 to 1. The left-hand side determines the height, where it touches the function to the right and down. The next rectangle is from 1 to 1.5. The left-hand side, x equals 1, determines the height to the right and down. And then the last rectangle here, the left-hand side, which is 1.5, determines the height. So I'll go up until it touches to the right and down. So what the Riemann sum is the sum of the areas of all of these rectangles. And what it gives is an estimate for the area for the curve underneath the function. Now we know that we could find the actual area would be the definite integral from -1 to 2 of our f of x dx. But this is to give us an estimate. So it's where definite integrals started. So to do this, I'm going to find the area of my first rectangle. It has the area of a rectangle is base times height, so it's 1/2. And then the height would be my f of -1. So if I look at when x equals -1, -1 squared is 1 plus 1 is 2. It has a height of 2. My second rectangle, I'm looking at a base of 1/2. And then I'm going to look at the height when x equals a -1/2. -1/2 squared is a positive 1/4 plus 1 is 1 1/4, or I'll just use decimals for this, 1.25. My next rectangle has a base of 1/2. And the height when x equals 0 is 1. My next rectangle also has a base of 1/2. I'm on this one, and it'll have the same height as this one over here. When I plug in 1/2, I get 1.25 plus a 1/2 for my next one, and it has a height of 2. For my last rectangle, a base of 1/2, and when I plug in the left-hand side here, 1.5, I have 3/2 squared plus 1 is 9/4 plus 1, 4/4, so I have 9/4 plus 4/4 is 13/4, or 3.25. And you can see that I probably should have drawn that a little higher to include it. Okay, so if I actually figured out what this is, I would have the left-hand Riemann sum. Now, just to note, because the rectangles have an equal bases, they all have this 1/2 here, so I could have factored out the 1/2. And I'd have 2 plus 1.25 plus 1 plus another 1.25 plus 2 plus 3.25. And this is generally how I will approach the problem because there's something very simple here. There's 1, 2, 3, 4, 5, 6 different heights. They all have the same base. Again, you can only do this if it has the same base, but I have 1, 2, 3, 4, 5, 6 rectangles, 6 different heights. It's a way to actually make sure that I'm doing it right. This adds up to 10.75 divided by 2, and your sum is 5.375. That is the area of those rectangles. So for the right-hand sum, we're looking at the same region from -1 to 2, and we're still looking at a delta x of 0.5. The difference is that the right-hand side of each one of these intervals will determine the height that we're going to find. So for this first rectangle, I don't use the -1, I use the -0.5. And I know that that has a height of 1.25. I found it above. For the next rectangle, I'm going to use the height at 0, the right-hand side. So the height right here is just 1. For my next rectangle, I'm going to use the 0.5. The height at 0.5 is 1.25. When x equals 1, the height is 2. When x equals 1.5, draw it a little better here, I know that that should be a 3.25. And then I will use the far right-hand side for the right-hand rectangle, and this has a height of 5. So doing this, I know that the base of each rectangle is a 1/2. So I can actually factor that out, or just think of it like this. It's a big distribution problem. It's going to be a 1/2 times 1.25 plus a 1/2 times 1 plus a 1/2 times 1.25 plus a 1/2 times 2 plus a 1/2 times 3.25 plus a 1/2 times 5. And when you actually figure out this problem, I'm sorry, I didn't finish drawing the sum there, it comes out to 6.875 for that sum. And you can see that it is more than the left-hand sum. Sometimes they'll be the same, sometimes they'll be different. It depends on the symmetry with the problem. So those are your left-hand and right-hand Riemann sums.